Okay, another few problems in reviewing for the exam. If you have a diagram with parallel lines and a transversal, such as what we have here, we know the lines are parallel based on the two arrows that we see. So, continuing, we should be able to find all the angles when one is given. So, in this case, angle 2 is 72 degrees, I believe. Yes, 72 degrees. So you can work your way around the diagram quite a few different ways. First of all, I would look at the diagram this way and say angles 1 and 2 are supplements. So if we subtract 72 from 180, we get 108 for angle 1. Next thing I would look for is a pair of vertical angles, such as angles 1 and 3 are vertical angles. So therefore, they are always congruent. So if angle 1 is 108, angle 3 is 108. And likewise, angle 4 has to be 72 because angle 2 is 72. Then we have to get down to the other vertex down below. So let's go back to the given information that angle 2 is equal to 72. You either want to look for corresponding angles that are congruent, are going to be congruent because the lines are parallel, or maybe alternate interior angles or same side interior angles that are supplementary, and there are others, but we'll just look at a pair of corresponding angles formed by parallel lines being intersected by a transversal. Corresponding angles are congruent. So angle 6 is 72. Or you could have said, because we already found angle 4 to be equal to 72, 4 and 6 are alternate interior angles that are also congruent. So another way of justifying the same answer. And now that excuse me, now that we have the measure of angle 6, we don't need the angles at the top anymore technically, so we can just work our way around this part of the diagram by saying angles 5 and 6 add to equal 180, so therefore angle 5 is 108, just like angle 1 was equal to 108 up above. Angles 5 and 7 are vertical angles, so there's another 108. 6 and 8 are vertical angles, so another 72. Okay, next we have something very similar. We have to solve for x and y on this diagram based on two pairs of parallel lines. So because we can look at the diagram this way, two lines are parallel, this line and this line being parallel, and a transversal. If this angle is 98, this angle over to the right here is 98, because that's a pair of corresponding angles. Now you can work your way around the diagram a bunch of different ways. If we focus in on this angle and this angle, that's another pair of corresponding angles formed by parallel lines, but now the line over on the right is a transversal, so therefore corresponding angles have to be congruent, so we have another 98-degree angle. And that gets us closer to solving for the value for y by looking at the diagram down at the bottom. We have two angles, the 98-degree angle and the value for y, which have to be supplements, so therefore you subtract 98 from 180 and you get 82 for the value for y. Now you can proceed quite a few different ways to find the value for x. I'm just going to put this 98 back in, and I'm going to say this angle and this angle are alternate interior angles. See the Z-shaped figure? So the inside corners of a Z are congruent angles if the lines are parallel, which they are, so therefore this angle is 44. And we'll get rid of some of the scribble here. And I'm just going to rewrite the 44. Now I can see that these three angles, x being included as one of the angles, they have to add to equal 180. So if the first two angles, 98 and 44, add to equal 142, then we subtract 180 minus 142, and we get 38 degrees for x. Next problem. Now we want to reverse what we were just doing. We want to figure out if lines are parallel. So you're going to look for corresponding angles that are congruent or not congruent, and or you could look for alternate interior angles that are congruent or not congruent and conclude whether or not the lines are parallel based on that. So I'm going to start right here and say these two angles add to equal 180, so if I subtract 78 from 180 I get 102. Now if I look at that 102 degree angle and this 101 degree angle, I can state that we have two lines and a transversal, and corresponding angles are not congruent. So therefore A is not parallel to B. So the first statement is false. The second statement. Looking at the bottom part of the diagram, I can see that these three angles add to equal 180. The first two angles, 37 and 42, add to equal 79. 79 subtracted from 180 equals 101. So this angle is 101. Now if I look at the diagram this way, these two angles are corresponding angles when I look at line C and line D being intersected by a transversal, line A. Because we have corresponding angles that are congruent, we'll get rid of that so we can see the 101 obviously equals 101. So because we have corresponding angles are congruent, C and D are parallel. So that's true. And one more diagram, just going over a few definitions. If we're looking for two parallel lines, two lines are parallel if, now we have a rectangular solid. I should have written down that it was a rectangular solid. So the top line in the front wall of the box is parallel to the bottom wall. So a pair of parallel lines would be something like line AB and line or segment CD. Two skew lines. Skew lines are two lines that are non-coplanar. So line AB, which we already have, we might as well start there, and a line such as line, what's that, CG, would be a pair of skew lines. It's impossible for one plane to contain those two lines, so therefore they're never going to intersect, and they're obviously non-coplanar, so therefore they are skew lines by definition. And two lines that intersect. Okay, so any two lines that intersect at one point, so I already have line CG down here being indicated, so we might as well start with that. And any other line that obviously intersects at point C or at point G, so line BC, that's a pair of intersecting lines. Obviously they both pass through point C. Good luck. We'll be back with another video.